Welcome to springlib.
All right, so two words I have for this problem, which are momentum conservation. So basically, you have a particle at rest that decays into a particle at rest, decays into a particle. Let's call two particles. Let's call one 1 and the other 2. Okay, and this one has zero. At rest, so it has zero momentum. So momentum conservation states that initial momentum will be equal to final momentum. So initially is 0, finally it must be 0. So the magnitude of the momentum, so momentum of particle 1 will be equal to momentum of particle 2. And we know that the special relativistic treatment of momentum is given by equation 26-4, which says that momentum equals gamma factor times mass times velocity. Okay, and we have masses and velocities given for all except 1. So in this case, so requiring this, we have that, requiring momentum conservation, we have that gamma 1 m1 v1 equals gamma 2 m2 v2. Okay, v2 is what we don't know, so we should find that. v1 we do know, and m1 we do know, and same for, and so we can figure out gamma 1. Gamma 1 is actually 1 over square root of 1 minus v1 squared over c squared, which is equal to 1 over 1 minus, remember v1 is 0.6c, so once you take the ratio of v1 over c, that's what you'll square, and so that's 0.6 here, and so that's just 1 minus 0.6 squared in this formula, and you get out that gamma 1 is 1.25. Okay, so that's great. So in your equation, now you have 1.25 times the mass, which is given as 6 of particle 1, which is given as 6.68 times 10 to the negative 27 kilograms. And then v, which is 0.6 times the speed of light. Let's keep things in terms of c, just to simplify our calculations. And you have gamma 2, which you don't know, times the mass of this second particle, which is 1.67 times 10 to the negative 27, so this would be a proton, times v2, which you also don't know, right? So you rearrange things and get everything in terms of gamma 2 times v2, and that comes out to be very nicely 3 times c, okay? So gamma, again, is this 1 over square root of 1 minus b squared over c squared, and so we write it out here. On the left-hand side, you have v2 over that square root term, and so we have gamma 2, so it's v2 squared over c squared is equal to 3c. Then you square both sides, and you get v squared equals 9c squared times 1, or 2 squared, so 9 equals 9c squared times 1 minus v2 squared over c squared. Okay, and so this means that v2 is 0.95 times the speed of light, and that's it.